Hello everyone. So now we have some wireless theory also in our syllabus. I hope you remember in CCNA also we have some theory. So some theory repeatedly used here also. Okay, so we will see this is a theoretical concept we are going to learn here. If you see design principle of WAN deployment, that is wireless deployment, and the location service in the WLAN design. So this one we are going to do, and also let me show you other thing here. Wireless, that is a layer 1 concept such as RF power, RSSI, signal to noise ratio, interference noise, channel, wireless client, and the AP access point, antenna type, and how the access point is going to join the WLC controller, and describe the main principle used for the layer 2 layer 3 roaming. Roaming means moving from one area to another area, and how we can do the troubleshooting for the wireless. So these all are the theories. So let's do this all together. And what else? If you see here, we have anything here for wireless, so we can cover all together. And this is the wireless verify security, so we are going to do this one also. So this all thing whatever I highlight, that is for the wireless. So all together we are going to do now. So let me open the wireless notes. So first of all, we need to have the basic background about the wireless. So wireless is nothing but without cable. We are going to send the signal by using without cable. So first of all, we are sending signal, that is communicating. So we will discuss some basic theory, basic scenario, basic wordings, and after that we are going to go for the main topic. So communication, what is the meaning of communication? If I am talking with you, you are talking with me, we can say we are communicating, like sending the information. We can say transferring of information from one point to another point, we can say communication. It is a simple definition. We can say transferring of information from one point to another point is known as communication. So if device is using the cable, that is wire, we can say wire communication. If device is not using the wire or cable, we can say wireless communication. Normally, if you see our cell phone, mobile phone, we don't connect the cable to them, right? We are using Wi-Fi, wireless signal. So we can say that is a wireless communication. An example, if your desktop, you are connecting RJ45 connection cable to access the internet or to access the server, resources, printer, that is known as wired communication. So just simple, we need to remember, if we are using wire, so we can say wire communication. If we are not using wire, so we can say wireless communication. So this is a basic example. Wire communication means how we will have the cable. We have different types of cable. Generally we are using the cat cable, cat5, that is Ethernet cable we are using. So it will connect to switch, or it will connect to the router. Depend layer 2 switch, layer 3 switch, depend organization to organization, 3-tier, 2-tier architecture, or 2-layer architecture, span and leaf architecture. Whatever architecture they are following, they are going to connect that one. So but here we are using the cable. If you see in this scenario, we have 3 server connected to the switch, and also printer, and we have some PC, that is a client, that is a host. 4 hosts we have. So this guy can access this 3 server, and also they can use the printer through wire. So we can say wire. And wireless, so wireless is nothing but, we can say Wi-Fi. Wireless, we are calling in the shortcut Wi-Fi like that. Wi-Fi stands for wireless fidelity. Okay, Wi-Fi service are defined in the IEEE 802.11 standard. There is a standard IEEE 801, 802, 803 like that. So this is a standard for the wireless, IEEE 802.11. IEEE, I hope you already know, that is the Institute of Electrical Electronic Engineering. So they are preparing the different protocol and the standard. This is an institute. So wireless network referred to use the infrastructure, infra or radio frequency signal. We are saying the wireless signal, but wireless signal is using the RF signal. RF means radio frequency signal. Radio frequency signal generally we are using. If you are using your mobile phone, you're talking with someone, it is using the RF signal. RF is nothing but radio frequency signal. And wireless technology are designed to reduce the time and the different types of obstacle created by the cable. Example, imagine if we have the cable for our mobile phone, how it is difficult to carry from one place to another place, right? We cannot carry the cable in our car. We cannot take one cable. If you are going outside, connect your cable, LAN cable, from your PC to your mobile phone and go anywhere. Very difficult, right? To overcome these types of issue, we are using the wireless technology. Okay, to overcome these types of issue, we are using the wireless technology. So now we can say we have different types of communication. We can say cellular, mobile communication, satellite communication. We are using different technique, but basically we are focused on the what we can say Wi-Fi signal, wireless signal, how we can control that one, how we can put the authentication on that one, how we can put the encryption on that one. If you see, this is one scenario. Here we are using the wireless router, our devices are connected. If they have the same authentication means password, they can connect each other. If they don't have the same authentication, they cannot. In packet tracer we can take that one. That is a basic lab. Let me check if I can show you. It is just basic. Already we learn in the CCNA level. We have the Wi-Fi router and we have some smart devices. Automatically they are going to connect. If you see, this is the wireless devices. If you click here, this all are the wireless devices. You have WLC controller, you have access point here, you have all the wireless. If you see, this is a home router and you can take the smart devices. If you go here, you have the smartphone. This is a smartphone, and if you see tablet, smartphone, they are connecting because there is no encryption, no password here, no authentication, so all are connecting. If we double click here, this is the what we can say our router. Example, in our home router also we have one for the WAN port, remaining for the LAN port. Okay, one for the WAN port. Maybe ISP will give you, you will put the cable here, that one, and this is for your home network. Okay, and if you want to access with GUI, you will click here, so this will look like this. Same like in our home router. When you log in, you will see this page. This is a DHCP server configure here, saying that start the IP from 192.168.0.100, and they are saying maximum user we can take 50, and they give the range from where to where start. So this is automatic configure DHCP server, so automatically we are going to get the IP from DHCP. And if you want to go more here, we can go here and we can give the SSID. SSID is nothing but the Wi-Fi name. So we are going to give the Wi-Fi name. If you want to put the password, we can put the password also here. It is disabled here, we can enable the password. There are different types of password, WPA, WPA2, WPA, enterprise, personal. We are going to see this password later. So we can enable this one. So this is a just basic scenario. We have the home router, and imagine your ISP cable will connect here, or maybe you will have the SIM card. Maybe you will have the SIM card. From there you will convert the SIM card signal in the RF signal and it will transmit. Okay, this is a basic scenario, just I am showing you. After that, what we can say, we have access point. So we are saying access point. What is the main function of access point? Why we need access point? Generally, if you want to convert the wire signal into wireless signal, imagine you have something like wire signal. Let me show you here. Imagine here, in this scenario, you have here one switch and you have some PC. Maybe I will take some PC. You have some PC here, all are connected with cable, and you have some smart devices here. Okay, this smart device will connect with the Wi-Fi signal only. If you see, this all are connecting with this router. This all smart devices are connecting with router, but let me remove this one. I will remove this one. In our network now, we don't have any Wi-Fi devices, that is device which can transmit and receive. So we will have this scenario. These PCs are connected with the switch and they can access the network, but these devices cannot. So what I will do, I will use the access point. This router, the router which we used just now, that router is having the feature of the access point also. Let me show you this router. I can connect here with the cable. Cable will go from this switch to this router. So this PC also can communicate with the smart device. And this one we are calling router, but actually this is a 3-in-1. If you see, this is the access point and also router and also switch. If you see, you have port switch here, like a switch. Ports, 4 port you have for LAN connectivity. So this one is a not a way we can say, this is a use for multi-purpose. This is behaving as a router and also access point and also switch, 3-in-1. So we can utilize. But generally, why we need access point? Wherever you want to convert the wire signal into wireless, we will use the access point. And wherever we don't have the signal, we can install the access point. Example, in your basement area, you don't have the Wi-Fi signal there. So what you will do, you will run the cable from the switch and you will install the access point. So with the access point, they can get the signal. So we have different types of access point. Depend, some are used for 25 user only, some are used for 100 users, some are used for 50 user. Depend organization to organization which they need. How we can find out which model is supporting how many user? We can use the catalog. In Cisco website we have the catalog, so we can check in that one. There is a manual, specification manual. In that one we can study how many user it is supporting. Okay, how many user it is supporting, it is power over Ethernet or not, because sometime it is very difficult to run the separate power for the access point. Let me repeat again, I am saying some scenario we have very difficult to run the separate power cable. We don't want to give separate power cable to the access point in some cases. So what we will do, we will use Ethernet cable only to give the power. If you remember, power over Ethernet, PoE, we have power over Ethernet. So what we will do, we will give the power to the devices through a Ethernet cable only. So in that scenario, we need to take the access point which is supporting the power over Ethernet. I think we can check here, maybe this switch will support the power over Ethernet. So generally, whenever you are buying the access point, you need to make sure where you are installing. Maybe you are installing in the basement area and difficult to run the separate power cable. Show, I remember some command we have, show power inline, something we have, show inline like this, to check the show power inline, something like this. Yeah, this command. If you see show power inline, this is why we are using this one, to check this switch is supporting the power over Ethernet. This is a layer 3 switch and it is supporting how much? 370 watt. This much power he will support. And this port is auto, and when you connect they will consume the power, so this power will reduce. If you see 15.4 maximum, this port can supply 15.4. So when you are buying the, what we can say, when you are buying the access point, you need to make sure it will satisfy this much power. It will not consume more power. If it is consuming more power, then you need to change the switch. Else you need to run the separate power cable. So generally, actually whenever you go for the organization, it is already set up. No need to install or anything. Already it is set up, just you will monitor, you will change the password, you will do troubleshooting. If you have any issue, if it is faulty, then you will buy the same model, you will replace. In the real scenario, what we are doing. But example, if you are in the implementation team, if you are working for like a implementation engineer, that is you are going to implement. If any new company is deploying the devices, your company is going to take the subcontract from them, and your company is going to supply the devices, install, configure, everything your company is doing, means you need to know about this detail. Like you are working as a consultant, you will go to customer, you will check their requirement, and then you will analyze, and then you will check which switch you need to buy, and which access point you need. You can ask the customer how much your user in this area. Example, 50 user will be connecting to net here, 10 user, 20 user, like that. Depending upon all requirement, we will finalize which one we will use. And if you have Cisco support, you can open the chat with them and you can give your requirement. They will suggest you which device need to use. Okay, so what we are saying, we will use the access point, power over access point also there. Depending upon our requirement, we will select. Capacity we need to look, and power over Ethernet is supported by access point or not, and how many users can connect to that access point, we need to look that one. And access point now divided into two different types. One we can say autonomous access point. Autonomous access point means stand-alone access point. Stand-alone means it will not connect to the controller. Generally we are having the controller, maybe you have two controller, maybe you have more than two controller also in the organization. If the organization is very big, you have 10 controller, wireless controller. Generally what we have, example, if you see the scenario here, imagine this is your network. I have one switch, okay, it is connected, maybe your parking area here, you have one access point here, okay, you have one access point here. This is your meeting room, you have one access point. Just I am drawing roughly. You have, this is your office area, working area, different places you have access point. Okay, you have different switches also. You have the trunk, again you have access point here. Yeah, maybe some companies are having 100 access point, 50 access point, depend. So why we use access point? If you don't have the Wi-Fi signal in this area, you will install the access point and you will connect to the switch. This switch is having the connection, so that wire signal is going to convert into wireless signal. But the problem here, this is 1, this is 2 access point, 3, 4, 5, imagine I am using 6, 7, 8, 9, 10. Total I have 10 access point here. So now in our real scenario, in our organization, we will have the controller, one controller, access point controller, that is WLC controller, wireless LAN controller. So we will log into this controller, and here we are going to configure and we are going to push that configuration. So that configuration go here and it will apply to all the access point. No need to log in individually. No need to look one by one. You can send the configuration to all the access point. You can select which access point you want to send. If you want to send all, you can select all and you can push the configuration. Okay, but your access point should connect to the controller. If you are using autonomous access point, then it will not connect to the controller. That will be standalone, so it will not connect to the controller. So if you want to do the configuration, then you need to do the manually, one by one. You have the GUI. Just what you need to do, you need to connect to this access point. You can connect with wire or wireless. If you have the cable, you can connect the cable. If you don't have the cable, if you have the password of this access point, just put that password in your Wi-Fi LAN card, in your laptop, and put the IP, whatever IP they are using, and put the login detail. You can access the GUI of the access point. And then you can configure or change whatever you want to change. If you have 100 access point, you need to log in 100 access points separately and do reconfigure whatever new configuration you want to put in autonomous access point. So now we need to remember, autonomous access point is nothing but standalone access point. We will use GUI or CLI to configure this one. It is not controlled by the controller, wireless LAN controller. Autonomous access point is not controlled by the wireless LAN controller. We need to log in separately one by one and do the configuration. If you have 100 access point, you need to log in 100 times in 100 different access point and do the configuration if we are using autonomous. Okay, but to overcome these types of problem, we go for the controller based access To overcome the autonomous access point problem, we are going for controller based access point. Controller based access point is the access point which is going to connect to the controller, and from the controller we are going to push the configuration. This device required no initial configuration. Controller based access point, no need to give any configuration. It is having zero configuration in it. It is also called as lightweight access point. Controller based access point, other name is lightweight access point. Lightweight access point is going to communicate with the controller, that is wireless LAN controller, and they are going to get the configuration, they are going to get everything from the controller. After that they are going to connect. Example, if you see, this is a scenario. I am having one switch here, network switch we are saying, that is layer 3, layer 2, maybe this is a layer 2 access layer switch, and then we can connect to the controller, and you can connect the access point to controller directly, or if you want you can connect this way also. Depends scenario to scenario, where you are, where is the location of your access point, near to controller or where. Depend different architecture, we can connect different way. From here access point you are getting the signal to your LAN card, and all access point is controlled by the wireless LAN controller. So this access point known as lightweight access point. Lightweight access point. And if you see here in this model we have different types of model also. Like we can use the WLC. From WLC you can configure lightweight access point in different operation mode. We can configure as a local, we can configure as a monitor, we can configure as a Flix Connect, we can configure as a sniffer, we can configure as a rogue detector. We can configure access point in different method. We can configure as a bridge, Flex bridge, SC Connect. So different types of configuration we can do. Depend company to company. Local means default lightweight model that offer the one or more function of BSS. Means normally just we are giving the, I can say, connecting, giving the signal to the host. Or monitoring means we will not transmit. When we put the access point in the monitoring, we are not going to transmit. We are going to just monitor the network. And we have different, like Flex Connect. Remote sites are locally switch traffic between SSID and the VLAN. So we are going to use, we are not using mostly, sometime we are using this sniffer. What is the meaning of this one? Means example, if you want to capture some packet, if you want to, same thing as we use what we can say just now, what span, we want to analyze the traffic. So same thing we can do with the access point also. And we have rogue detector. So with this one we can detect if we have any malfunction is going on here, like any attacker is attacking or any device is attacking our network, we can do with this one. So mostly we are using this one, or normal way. Normal means local, just giving the signal to the device. And sometime if you want to connect the more access point, we can use point to point and point to multi-point from access point also, like a bridge. So different way we can organize access point. The main function will be what we can say, access point is used to convert the wire signal into wireless signal. And then we have antenna. Antenna is nothing but, like we can say, this is a metallic wire which is used to transmit or receive the signal. Generally we have the omnidirectional antenna, we have the different types of antenna, Yagi-Uda antenna. But why we need antenna? Antenna is used to transmit and receive the wireless signal, that is the RF signal. RF signal is nothing but radio frequency signal. So we can say we are using antenna to transmit or receive the RF signal. And we have different types of antenna. Omnidirectional antenna we have. So he is going to transfer the signal, that is a Wi-Fi signal or RF signal, in all the direction. Omni means all direction. 360 degree he is going to cover. And directional means in particular one directional. If you see, this is a omnidirection. In all direction he is going to transmit the signal. And if you see directional, example is Yagi-Uda antenna. Yagi-Uda antenna is example of directional antenna. So it will particular direct. So depend scenario to scenario where we need. But generally nowadays everything is coming as a, what we can say, inbuilt. If you are taking the new access point, it is very small, it look like CCTV camera. You don't have antenna anything outside, it is inbuilt inside. We cannot see where is antenna, it is inbuilt. Okay, so we have different antenna. Generally we have the omnidirectional antenna. So let me stop here. We will record another video. This is a part 1, else video become lengthy.